Welcome to programming in modern C++. We are in week 4 and I am going to discuss module 20. In the last module, we concluded our discussions on operator overloading, looking at how to overload operators using global function, member function as well as friend function, and how it can be used to build more complete algebra of user defined types. In the present module, we will take up another concept which enhances the readability and expressibility of C++, provides a lot of engineering benefits. It is called namespace. So, this is the outline of things to expect. So, let me define what is namespace. Namespace is a declarative region that provides a scope to the identifier. You are familiar with the scope, right? You know function scope, you know block scope, you know global scope, right. So, you know that every time you put a pair of curly braces, you are creating a scope. If it is associated with a function, you have a function scope. If it is not inside any function, it is in the global scope. If it is associated with a class, then it is class scope and so on. Namespace provides a class like modularization, but without the semantics of the class, which creates a very strong paradigm where the file level scoping of C static can be avoided. You know, in C program file and therefore, in C++ program file as well, you can declare a variable to be static or a function to be static. What it means? That this is local. So, if I have two files, say file 1.c, I have another file 2.c and I have int x here, then I can use this extern int x in a different file. So, what happens is this is meant to be a global variable which can be referenced here. If I do not want that to happen, then I can write it as static, say int y. I can write int y in the other. Now, what it means is this static int y is available only within this file. It is not available here. This is not same as the global int y that you have. So, this is called the file local scope, which is very useful because when two developers are developing into different why was this given in C is the basic fact is when two developers are developing at the same time, they are writing into different files and it is quite likely that they will use the same name. Now, if they use the same name, but they are not actually the same variable. If they are actually the same variable, then one except everything else will be externed and linker will put them together. But if they are not the same name, so if I in this I have int z and int this too I have int z, then it is necessary a linkage error because you are defining two different global variables by the same name, right? This is which is not permitted. Right. So, file the static in the file scope was provided in C to take care of such situations, which is eliminated by the use of namespace. We will see how. So, let us first look at a program. The namespace is defined with the keyword namespace and then the name of the namespace. So, you can see that the syntax is very similar to struct or class except for the keyword. So, what I have is a in this namespace, my namespace, I have made different declarations. I have declared a data, I have declared a function, I have also declared a class. Now, all of these names are scoped inside the name of the namespace. What it means is if I had declared, say somewhere here, if I had declared int my data, then how do you refer to my data? By my data, it is global. But in this case, the name of my data is qualified by the namespace name, that is called the namespace scope. So, when I say my namespace colon colon my data, it means this particular variable. When I want to talk about this function, I write it as my namespace colon colon my function. Name of this class is my namespace colon colon my class. So, it is exactly like the class scoping that we have already seen, the name scoping in the class, the qualified names in the class, but namespace is just a grouping. It has no other behavior like data member, public, private, instance. It is just a lexical concept. It is just a syntactic concept. It just allows you to resolve your names, structure your names in a nice way. So, that is the way you use the namespace. So, what are the different scenarios? Let us say, I will just illustrate you some of the pitfalls where namespace can really help. Let us say, talking about the C standard library stdlib, there is an abs function which takes the absolute, which gives you the absolute value of an integer, right. Now, suppose you want to create a specific abs function, a special abs function, so that it will return the absolute value of parameter n if n is between -128 and 127. Otherwise, it should return 0, right. So, it is like a, so it is 0, it is 0, and in between only, if it is positive, it remains positive, if it is negative, it remains positive. So, between -127 to 128. You want to do this, you want to write this function. Now, if you have to do that, then you will write a function like this. If n is less than -128, return 0, greater than 127, return 0, otherwise return minus n. It is not difficult to write that function. The question is, what do you call the function? The moment you give it the name ABS and have the same signature, what it does, it hides, it will hide the original function in the C stdlib library. So, now whenever you use ABS, it will use your function only. This is what you get. So, there are two aspects. One is, if you do not want to use a different name for ABS, because that is not semantically expressive, you do not want to call it my ABS, that can always solve the problem, but you want to call it ABS, but provide it with a different definition. You cannot do that without hiding the original function that exists in the library. So, this is the basic problem of name clash. So, you have a name in the global already, int ABS int, and you want to create another identity for that name in your space. So, that is where the namespace can help. What you do is, you do not clutter the global space, you write your function, but put that into your own namespace, say my NS. If you put it in your namespace, then what is the name of this ABS? The name of this ABS is qualified by this. So, when you want to use your function, you call it with the namespace qualifier. When you call it independently, separately, without the namespace, just call it as ABS, you still get the global function that exists in the cstdlib. You can see the differences in the output to understand this. We are doing it for -203, -6, 77, 179. So, these two are within the range of -128 to 127, and these two are outside. So, here you get 0 0 and here you get the absolute value, whereas if you use just ABS, which is from cstdlib, in every case you will just get the corresponding positive value. Right. So, this is one place where namespace can be really useful. Let us look at a different problem, not, I should not say different, but an extension of this problem. Think about an organization that is developing an application to process student records. So, class ST is for students and class ST register is a list of students. Right. So, here we try to define the class ST and class ST register. It has a type def for enumerated gender. It has a constructor which constructs a student record with the gender. It can set roll number, it can get the gender, and it has an output operator. You have just learned how to do that, and it has the name, gender and role as its private data members. Similarly, in the registry, all that you need is a list of students. So, it is array of these pointers, and you want to know what is the number of students, and you can have constructor adding a student and getting details about the student. This has got nothing to do with namespace. I am just trying to create the context for a near real situation. Now, after having written this, let us say the organization has a lead engineer called Purnima, and there are two developers by the name of Shobita and Nicolai. Right. So, Purnima writes these classes, your ST class and ST-reg class, the header file says student.h, and then allocates the task, divide the task of implementation to Shobita and Nicolai. Right. So, both are given student.h header to work with, and Shobita is told that please write all the code that are specifically applies to the male students. Nicolai is told write all the code that specifically applies to the female student. Right. So, I mean what those codes can be, what differs, what their requirements and all that, we are not getting into all those. So, because that is not relevant for us. The point is that both of them will work with the same set of classes and write separate applications for certain subgroups of objects. Shobita for male student object, Nicolai for the female student object. And just to model, this processing function is, say, it is just printing, it is for male students. It is printing the student record if it is a male student here, the female students and female record and so on. Right. And corresponding to this, they create application, main application, where they test it, taking Ravi as an instance and gender as male, and check that the registration and processing are happening fine. So does Nicolai. She creates Ria, whose gender is female, registers and processes this. Right. So, but once Purnima has given them, the input to them is the processing requirement, and in terms of code, this student.h header file which has the classes. Otherwise, they are working independently mostly. Now, after they are done, then they give their code back to Purnima. and who has to integrate, because finally the application has to work for both male students as well as female students, and she has to integrate both into a single main function in her main function. So, she also includes student.h. She includes the processing function header from Josuttis as well as Nicolai, includes the instances that they have created, makes a call as they did. But this integration, as you can see, will fail because of the name clash, because what happened is Nicolai and Josuttis both have chosen to use the same function name. Therefore, when Purnima has to integrate code from them, then naturally there are two proc st functions in the same project which cannot exist, right? And you do not know which one is being called. If you have this, you do not know that it is from app 1 by Josuttis or it is from app 2 by Nicolai. Right. So, this becomes now a real nightmare. Now, I am just trying to highlight the problem at a very, very minuscule level and pathological level. But in even in a medium sized project with 5, 6, 10 developers working on different parts, such type of name clash is very, very likely to happen, because everybody has a kind of inherent tendency to put natural names, right. So, if I am working on electronic circuits, I will call a adder as an adder, and my friend Shomir, who is working on other type of adder, will also call an adder as an adder, and the function names, global names all will start clashing. So, this has happened umpteenth time in the industry, that because of such. Now, if it could be planned and designed thoroughly, that well, this is the name you use, this is the name that you will use, often that is not the case, often that is not. If Purnima had to do so much, then possibly she would have written the code herself. She has created the skeleton, the classes given to Josuttis, given to Nicolai, told them to do details, and they come back having a number of name clashes. So, the way to one way to very quickly resolve this is to basically put these into different namespaces. So, what Purnima does, she puts a namespace app 1 for Josuttis code and namespace app 2 for Nicolai's code, puts everything there. So, what now happens? What happens? The proc st, which was proc st and proc st, was clashing in the name. Now, this becomes app 1 : proc st, this becomes app 2 : proc st, they become different. So, once you set the namespace, then you can either work as Josuttis or work as Nicolai. If you just change the namespace, then it is a different code space that you are working in, without actually having to change the code, edit the code that are embedded inside. So, all that Purnima does, she puts them in the different namespaces and qualifies the name. With this, the clash is resolved. So, that is this is one of the very big advantages of having namespace. Besides, there are several others, but this is one of the big advantages, that you can do quick engineering of merging code spaces from different without bothering about the name clash. And I just talked about two developers doing this. It could also happen that you have a lot of developed code and you decide to integrate with a third party library. That third party library has global symbols, you have global symbols, and then the clash. So, it is always a preferred practice in C++ that when you work for your particular sub project, sub module, or for yourself, you do everything inside a namespace which is unique for you, so that there is no possibility of clash with other global names. So, what are the features of namespaces? So, just a quick set of details. A namespace may be nested within another namespace. So, I have a namespace name1. This is something which is outside the namespace. So, it is global. I have one namespace and I have another namespace within that namespace. So, what it happens is basically the scope resolution gets nested. So, this data, the data which is global is called data, no namespace. The data which is just in name1 will be name1 : data. That is a. Now, what is this data? This is name within name2, but name2 itself is in name1. So, the actual name of name2 is name1 : name2. Therefore, the data they are in is that : data. So, this is basically given in this way, right. So, you can nest it in any form, right. So, very simple logic, all intuitive things that you get in terms of this. Now, often what happens, as we saw, names 1 : name 2 : data, you have to write long prefixes. So, there is a shortcut feature given, which is through another keyword using, and we say using namespace. You must have seen this line couple of 100 times by now, but what does that actually mean? What it means is, this is a shortcut to say that if I have a namespace name1 having 2 symbols and another namespace name2 having 2 symbols not nested, I can specify by saying using namespace and then give a name of a namespace or a specific symbol. Okay. So, when I just write this using namespace name1, then subsequently whatever I write, the symbols will be looked inside that namespace. So, for example, for name1, then I have written V11, but V11 actually is name1 : V11, but I did not have to write that, because I have said using name1. So, when I do V11, it knows that it will look for the scope of name1 and it will access this. I can do V21, I have V12 after this. I can, it is not necessary that I will have to call it V12, I can always also use a fully qualified name. I could have called it as V12 as well, but I have written it as V1 name1 : V12. Similarly, in the other, I have said that using name2 : V21, that is here the using is not on a namespace. So, I have not said namespace, I have just said using this, which means that it is a symbol inside some namespace. So, then so it is name2 : V2, that is this one. So, when you say V2, it actually means this. I do not have to say anything else, but and I can do fully qualified also. But mind you, see the difference that if I put V22, which is in name 2, I will get an undefined error. Why? But for V12, I do not get, I will not get, I mean I can use simply V12 and that will also be perfect. Why is this difference? Because in case of name 1, I have put a using on namespace overall. So, all symbols in that are in the available list, but here I have just specifically said that I am going to use V21 from name 2. So, I have not said that I will use V22. So, it will, if I have to use it, I have to specifically say name 2 : V22. Now, naturally this way it, I mean lot of writing can be shorten, but it might lead to other problems also. For example, if I had say suppose I had a symbol V21 here also, then with this I will have a problem, because what happens if I talk about V21? The fact that my name1 namespace is default, it means the V21 here. But I have said that name2 : V21 must be default, but that is a different variable. So, I have to make sure that by this using, I do not again by using what I am doing, I am again shortcutting the names. So, I am creating possibilities for clash again, right. So, this kind of using will have to be avoided. Now, the question is what happens with the global names? There is a data here, there is a data here, and I am saying using name1 : data, which means that if I say data, it means the data of name1. So, when I say data, now it means data of name1. If I say name1 : data, it also means data of name1. How do I talk about the data in the global? So, with this using, I am hiding the global data. The global namespace does not have a name, right. So, there is a special syntax given where you do not have a name, but you just say : which means a global namespace. So, if I want to refer to the global data, I just write it as : data. So, writing data will mean this one because of this using, but writing : data will mean the global one. That is how you can access all the namespaces appropriately. So, now you can understand the STD namespace we have been talking about. So, all C++ standard library components are put under one single namespace STD. So, that leaves the global namespace completely free for the user. You can put anything there, though it is advised that you do not put anything, you put in your own namespace, but you are free to do that. So, if I have to access symbols from this, so I have to typically write it as STD : only then it will work. So, when I put this using namespace STD, I mean that these symbols should be looked into this namespace. So, STD : Cout can now be written simply as Cout. That is a basic difference. Right? So, that is the reason we always keep on doing this, and if we do not do that, then we would have to put the fully qualified name in the STD namespace where all standard library symbols belong. One very nice thing about the namespace is they are open. What it means that you can define a few symbols in the namespace. For example, I am doing here in a namespace called open. Then I can again say namespace open and add symbols to that. This is not something that you can do in a class. So, it is not that whole of the namespace has to be created together. So, for example, all of the standard libraries put in the STD namespace, but if I want, I can again say namespace STD and add 5 symbols to that, right. So, this is so what happens is when you with this when you say using namespace open, it means this as well as this, as if all of them have been taken union of, as if they were declared at the same point, but they were actually not. And then x and y will refer to the respective one. You can figure out from the output that they are resolved and getting accessed properly. Comparing a namespace with a class, very easy. Every namespace is not a class, but every class defines a namespace. We have been talking about this. Namespaces can be reopened and more declarations can be added. Classes cannot be reopened. No instance of a namespace can be created. It has no sense. Class has multiple instances. Using namespace is a shorthand for name qualification. No such thing exists for a class, even when you are say defining the static variables and so on. and namespace may be unnamed also. That is, I may just say that is not putting anything here, just say this, which just guards it from any other namespace or global, but does not allow you to reopen because there is no name, right. It can be done only once. Right. So, these are some of the specific things that happen. So, with the introduction of the namespace, now if you look at, we have a wide variety of lexical scope that is available. I started talking about that. We have lexical scope in C++. Its scope is within which a particular name has a binding, has a meaning, is available as a variable or a function or class, etc. So, you have a scope for the expression, which is restricted to only one expression. You have a scope for the block, which is a local context, you know what is a block. You have a scope for the function, you have a scope for the class, you just learned the scope for the namespace, and you have a file scope where I explained the meaning of the word static for a in the file scope, which is again not something that you should be using anymore, and you have the outermost global scope, which again you should not be using except for putting your classes. Right. So, these are your different lexical scopes that are available in a C++ program, and scopes may be named or unnamed. So, named scopes are class scope, name scope with a name, global when qualified with colon colon. Unnamed scopes are expression scope, there is no name given. Block scope, blocks cannot be given name. Function scope, no separate name, same as the function. The file scope, again there is no separate name, and they may be nested or not nested. Block, class, namespace, this can be nested, but expression, function, file or global scope cannot be nested. So, this is a overall scenario in terms of the scoping in of different symbols in C++. So, we have understood and talked about various aspects of namespace as a scoping tool in C++, which is of great use and importance in terms of organizing the symbols, particularly at a global or near global level, and we have studied different features for that. Thank you very much. I hope you have enjoyed this discussion, and be very careful as you start your engineering projects. Be careful to define your namespace, define the namespace of your sub module properly, and then work on it, so that you will not be having nightmares with name clashes. Thank you very much.